Hi everyone. Today we're going to talk about nodal points and camera calibration again, as you may have guessed by the big checkerboard on the screen and some of these other calibrating looking dialogues here. The difference this time is the calibrator is built into Unreal 4.27. It handles lens distortion as well as finding the entrance pupil or nodal point of your camera. So it's pretty much an all-in-one. The only bad thing about it is that the documentation that they put up on the Unreal site was a little confusing and had a few omissions. So I want to go back over it with you and show you how to use it. You also might find it useful to have the Unreal Camera Calibration Quick Start Guide open while we're doing this, and I'll leave a link to that up at the top of the screen. First thing we need to do is create a project to work in. So I'm going to launch 4.27. And then in the Select or Create New Project dialog here, I'm going to choose Film Television, press Next, choose Virtual Production, press Next, name the project, I'm going to call it Calibration, and create it. You should get an editor screen that looks something like this one. Now we have to enable a couple of plugins, so we'll go to Settings, Plugins, and we want to find the camera calibration and enable that. And you'll get a message like this one that says it's beta, so just say yes. The other thing we need to make sure is on is LiveLink. So LiveLink is enabled, and we also want LiveLink XR to be enabled. And then we can restart the editor to make those installed. Now, before we go on and set up our calibration scene, one of the things that the Epic documentation didn't mention was that you have to set up a camera input. Now, if you've been doing virtual production, you probably already know how to build a media bundle and set up the camera input. But just for good measure, I'll show you how I do it here. I have an Aja card. The procedure for a Blackmagic card is very similar. So you start out by coming in, and you probably can't see it on the screen here, but you go down to Media and select Media Bundle. And you get a new media bundle. Now I'll just call that Aja, and it creates some other things here for me. Then I go in here and I set up my card, Aja Media Source, and in my case I'm running everything at 4K this time. Input 1, 4K UHD, progressive 29.97, and I press apply. And also for my setup, I need to come down to video here and say I'm using 10-bit and sRGB. And then I can save that and close it. Now up in the map that you're working on, to make sure that this device is running, you need to take it and drag a copy of it into the scene somewhere. And you can see right now that's the area of my studio I've set up to do the calibration in. You want to move this down out of the way. Now, right before we set up the rest of the scene, you want to come to View Options. I've made it smaller so you can see the whole menu. And you want to select Show Engine Content and Show Plugin Content, which I've already done here. That's going to allow you to see some of the content that you'll need to finish the calibration. So now you can find a nice blank space in this world here. And you go to Cinematics, and get a Cine Camera Actor and drop that into the world and kind of move it up so that it's not buried in the floor. Now go down into your content browser and open up this little sidebar and go down until you see Calibration, Camera Calibration Content. And click on that, click on Devices, click on Tracker. Now here you've got two choices, BPUE Tracker and BPUE Tracker 3. Most of us probably have the BPUE Tracker version 1 or 2. That's the somewhat larger one. If you've got that, you want to use this tracker. If you've got the brand new Tracker 3, which is a smaller tracker, you want to use this one. It's important that you pick the right one because the little green light on the tracker is in a different spot on each one of these, and it's going to be used as a reference later. I have the version 2 trackers, so I'm going to drag one of these up and drop it into my scene. And it's kind of small, so you really can't see it very well, but there it is. Now we do a little bit of setup of the Cine Camera Actor. Select it. Then over here in Details, come down to Film Back. And you need to set the sensor width and height to your camera. In my case, I know it's 35.7 wide and 20.081. Now it's important to get these numbers correct or your calibrations and nodal point finding later on may not work. If you don't know the sensor width and height for your camera, you can probably find it in your camera's manual or on the internet. One thing that is important here is that not all cameras use the entire sensor for shooting video. It might be a little bit harder to figure out exactly how much of your sensor is being used if you don't know for sure. In my case, my camera has a sensor that has a 3:4 aspect ratio. So when I'm shooting HD, which is 16:9 aspect ratio, I have to throw away some of my sensor height because it's not going to get used. So basically I've just divided 35.7 by 1.777 to get the sensor height that's being used for my camera. For your camera, it may be different. I can't really give you too much guidance on how to figure it out other than looking at the manual. Another good source sometimes is a site called dpreview.com, which has fairly exhaustive reviews on just about every camera out there, and they usually mention how all the video modes work. You also need to add a component to the camera. So we come up here and say add component, and we're going to add a LiveLink controller. Next we need to connect up our trackers. And I'm going to give you one tip here about Steam that may help you out. You've probably noticed that Steam occasionally just goes and shuts itself off if you don't use it often enough. So one of the things you might want to do before you start this process is to go down into the Steam VR menu, Devices, Base Station Settings, and turn Power Management off. Later on we'll come back and turn it back on again, but for now it'll mostly keep the system from shutting down while you're working. I'll now go up into the window menu and open the LiveLink window. Press on Source, LiveLink XR Source, and in this case I'm just going to track my trackers for now and say Add. And you can see my two trackers that I've got running here are up and they have a green light, which means they're working. In my case, the tracker with the A in its name is attached to the camera, and the other one is just floating around here. Next is something that may be a little bit confusing. In Epic's documentation, they talk about creating a fizz source, and at first I didn't realize what fizz meant. Actually, it means focus, iris, zoom, and it's the three pieces of data that come from a lens encoding system, if you happen to have one. Unfortunately, most of us don't have a lens encoding system, so we have to do a stand-in for the lens encoder. This lets us manually set up whatever focus, iris, and zoom settings we happen to be using. If you happen to have a lens encoder like a Glassmark or an IndyMark system, I'll put a link up at the top of the screen here that goes to a video they made on how to set it up to use it with this. But since most of us don't have an encoder, I'm going to show you how to make the fizz object and work without it. So to make a fizz object, you need to right click in the content browser here and go down to LiveLink and say Blueprint Virtual Subject. And you'll see we get to select the role and we want LiveLink Camera role. Press OK. And we're going to name this Virtual Production Fizz, and now we're ready to set it up. Double click it to open the blueprint editor. We need to create a very simple blueprint here. First off, we need 3 floats, and they're going to be called focus, iris, and zoom. And we want to click the little eye icon to make them externally editable. Now right click and search for Update Virtual Subject, Static Data. And click on the static data pin and split it. Connect this to your event on Initialize. And you want to click on Focal Length Supported, Aperture Supported, and Focus Supported. and turn off the location and rotation supported. Right-click again, and again we search for Update Virtual Subject Frame Data. You also want to split the structure pin up. And wire it to the event on update. And this time we want to connect our variables here to the appropriate places over here. So I'm going to drag them out. And we'll connect focus distance to focus distance. Zoom to focal length. And iris to aperture. Then compile this. Now is also a good time to set the defaults for your camera. For me, my zoom is usually at 24 millimeters. Right now, my focus distance to my test chart is going to be 180 centimeters. And my iris is going to be f22. And I'll compile again. Now we need to add that to our LiveLink. So we go to the LiveLink window and click Source, Add Virtual Subject. And you should see your virtual production fizz source right here, and we add it. The next thing we need is our lens file. So again, we go into the content browser. We come down to miscellaneous, which is kind of off the screen, sorry about that, and select lens file. And we get new lens file. And you can name this whatever you want. I'm just going to call it My Lens, and we'll come back to that in a minute. Now select your Cine Camera actor and we'll do some final setup here. First thing we need to do is go to our LiveLink component controller. And you see here it says none for the subject, and I want to set that to my actual tracker, and the default should be fine here. We need to add another component. I'm going to add another LiveLink controller. And this one we're going to connect up to our virtual source that has the fizz data in it. And while we're doing this, we're going to go down to the roll controllers section and find camera roll here. Open it up. Open up the camera calibration settings and the lens file picker. And select your lens file that you made a minute ago. Now select your tracker that we made earlier. This will be either BPUE tracker if you use a version 1 or 2 tracker, or BPUE tracker 3 if you use the 3rd generation tracker. Now you want to scroll and select the LiveLink component controller, and we want to hook it up to the actual LiveLink tracker that's going to drive this, like that. And the last bit of setup is to get our camera calibration checkerboard target into the scene. To do that, we come up here and we can search for checkerboard in the place actors area. Just drag that and drop it any place. Then go over to the details section of the camera calibration checkerboard, and we need to set up rows, columns, and the size of the squares of our checkerboard. Now, what I did for my checkerboard was I went to the Unreal instructions. I got this checkerboard here that they used, and I printed it out. Generally, you want to print it as large as you can. That'll make it easier to use. Just make sure that there's a bit of white around the edges so that the squares don't go all the way to the edge. You can use pretty much any checkerboard pattern. Just make sure to enter the data on it correctly. Now you probably notice that this checkerboard looks like it's 10 by 14. For some unknown reason, count the last square. So we need to enter 9 by 13, and my checkerboard is 1.7 centimeters. You can use whatever checkerboard you want in any size you want. Just make sure all those numbers are correct. And the last bit of setup for the checkerboard is to give it some materials. Black and white works, but it's a little bit hard later in the process, so you'll see that. It's better to have 2 different contrasting colors. So what I'm going to use is blue. There's already one out there, and I'm going to use red. And that's pretty much all the setup you need before you start calibrating your lens. To start calibrating, we're going to go into My Lens file, which initially looks like this. We start out on the lens information page, where we're going to put in the name of our lens and the serial number and the sensor dimensions. I'm just going to call it My Lens again. Use 1, 2, 3, 4 for the serial number. And the sensor dimensions are from the setup we did earlier, 35.7 and 20.081 for my camera. Your camera will be different, remember that. Then you click Save Lens Information. Now if you look down here where it says Raw Fizz Input, you'll see it's showing focus 180, iris 22, zoom 24, which is the stuff I set up earlier as the defaults for my camera. Now I need to set up the curves for the fizz input. Now if you had a lens encoder, this would map from whatever the lens encoder output is, which might be 0 to 1 or some large number, down to the actual values on your lens. And you need to set all that up. But since I don't have a lens encoder and we're doing this manually, I'm just going to set it up to pass through the fizz input without changing it. To do that, I'm going to add some points to focus, iris, and zoom. So for focus, I'm going to add a data point and call it 50, and the encoder mapping for that will be 50. And then I'm going to set up one, which is basically for infinity. We'll call that 1,000 centimeters, and we'll say the mapping is 1,000. You can see now we've got a chart here, and basically it's a one-to-one mapping. So right now I have the raw value at 180, and it's going to come out into the system at a focus distance of 180 like you see down here. And now we do the same thing for the iris. My lens starts at f2.8. And it goes down to f22. Now we have the curve for that. We don't need to do one of these curves for zoom because the calibrator is going to build that one for us based on the lens calibrations. And that's basically the hard part of all the setup. Now we're ready to go to actually calibrating the camera. So we go back to the calibration steps page, and we click on lens distortion. Make sure lens distortion checkerboard here is selected. And we're going to temporarily move this out of the way because there's one more thing we have to set up. If you go into the world outliner, you'll see that under camera calibration, we now have this media plate. And this is a media plate a lot like what you get when you set up composure. And it's also one of the bits of the setup that the EPI documentation was missing. This only appears when the lens calibration file is selected and the window is open. And every time you open it up, you have to reset it. So you click on it, and we need to come down here to Input, expand this out, and where it says media source, you'll connect it to the media texture that you built early on in this tutorial. And now you should be able to see through your camera. And I'll bring the My Lens file back up here. And you can see it looks kind of odd. That's because it's mixing the Unreal view with the live view. And you can change that mix up here with this slider. It's also not going to look quite as good as it does in your main camera window. I'm not sure exactly why that is. They just process it differently, I guess. But don't worry about it. If you need to use a window to focus your camera, you can always open this one up to larger, or just use the viewfinder on your camera. At this point, you want to make sure everything is set up on your camera correctly, that you've got the right f-stop, the right zoom, everything's in focus. And you want your camera to be on a tripod for this. Now we need to capture a bunch of images for the calibrator to use. To do that, you want to get this checkerboard in a number of different positions around the edges, near the center, pretty much every part of the screen you want to cover to get the distortion values for your lens correctly. So what I'm going to do is start out by moving it over to one side and all the way down into the corner. And to capture an image, you just take your mouse and click in this window. And you'll see the image here. And you'll notice there's some lines and things that show that it detected the squares. If you don't see those, there's a problem. Now for the rest of this, I'm just going to go through it really quickly and speed the film up so you don't have to watch me do it in real time. After collecting all your images, you press the Add to Lens Distortion Calibrator button, and you get this reprojection error dialog. Anything below 1 is considered pretty good. You can improve it by going back and adding more images. So as you saw, I collected 13 images, and then I pressed Add to Lens Distortion Calibration right here, and all of a sudden we have some calibration information. Now I happen to know that these are pretty close to correct because I've calibrated my camera with other tools before and got the same numbers. You can see it came out with a focal length of 24.7, which is just about right. The FOV matches that lens, and these distortion parameters here match what I got from other calibrators. So I think we're doing pretty good. The next step is to get the nodal point, which is what makes virtual production work correctly, and what we've always had trouble doing before because we were doing it manually. From this point on, you do not want to move the camera at all. Keep it stationary on your tripod. If you accidentally bump it or move it, or you just need to start over because you're getting weird results, come back to this point and do the checkerboard alignment over again. So now we go to the nodal offset section of the calibrator, and we start by saying nodal offset checkerboard, and we move the checkerboard roughly to the center of our camera image like it is here, and capture another image by clicking on it, and you see it captured the corners of all the squares on the checkerboard, and then we press Apply to Calibrator. And this is where the transparency part comes in. If you slide this back and forth, all the way over this way you're seeing the camera, and all the way over this way you're seeing Unreal. And you can see that the checkerboard in the real world and the checkerboard in the calibrator match perfectly, which is exactly what you want. If you go back to the 3D view for a second and take a look at what's going on here, you can see the camera here, which is pointed in a strange direction, I'll admit, but don't worry about it, is pointed at the actual checkerboard, which is up here. So the last step of this is to get the nodal point, and for that we use another Vive tracker. If you're working by yourself, you probably want to set this up with the Vive tracker on something like a monopod or tripod, or some kind of selfie stick with feet. If you can't do that, do your best to hold the tracker so that the green dot is facing the camera, and hold it still as you can while you're doing this last part. Okay, here's how it works. You can see I've set my tracker down in the image, and now I say nodal offset points method, and you make sure your calibrator is pointed at the other tracker object that we created early on. Now you take your mouse and you find the green dot on the tracker and click it, and then you move it to a new location. And repeat. And again. And again. One more. Now for this to work, you need at least 4 samples. I've taken 5. Here comes the trick though. It doesn't work every time for some reason, and I can't really figure out why. So at this point we're going to hit the Add Nodal Offset Calibration button here, and we'll see if the calibration makes sense. And actually it looks like it worked pretty good. You can see the nodal point offset right here, and that looks pretty close to the numbers that I've reached with other calibration systems. So I think we're doing reasonably well. The other test to see if it's working is to just move the tracker around and see if it follows. And I think you can see from that it pretty much does. Now I can tell you this location here is not exactly right because I have measured my camera rig pretty carefully, but it's not off by much. You can repeat this last process as many times as you like to try and get a better result. In any case, it's good to have done a nodal point measurement on your lens before you use this method, just so that you know that the nodal point is coming out right, or at least close to right. If you've measured it manually and estimated the nodal point, it should be about the same here, both the rotation and the location of the offset. If it doesn't come out right, just repeat the process a few more times. If you need to restart completely, if you think that you're just not getting any results, you can go back to the lens file panel here, click on nodal offset, and just click on this X. That'll delete all the nodal information you've grabbed so far and let you start completely from scratch without redoing the distortion calibration. The other test you can do to see if everything's working right is to move your camera like this. And again, you can see that everything is staying aligned. There's some lag in the tracker, but that can be easily fixed. I know from previous calibrations that I've done that my tracker has a certain amount of delay to it, so I'll just enter that in here. It's about 0.14 of a second. And now when I move the camera, you can see everything stays pretty close to perfectly aligned. If you close this and drop back and look at the real world in Unreal, you can see here the camera is now pointing at the tracker, and when I move the camera moves. Now what this has done is it's applied a lens distortion to this camera, so actually the Unreal image is being distorted to match your real camera. Some people prefer it the other way around. You undistort your real camera to match Unreal's perfect camera, but either way works. And actually, distorting the Unreal camera has some advantages in that you don't end up with any clipping or empty spots around the edges, which sometimes you see depending on the type of distortion your camera has. So this should work very well for your virtual production. So what we have here is the My Lens file, which contains both the nodal offset or entrance pupil offset and the information on the camera's distortion. We also have the Fizz file, which we use to transfer over manually the focus, iris, and zoom information. Now all this has been done for a camera that only has one setting on its lens. If you have lens encoders, it gets a little more complicated. What you have to do if you have lens encoders is repeat the process that I just showed you for different settings of your zoom, focus, and iris. The biggest effect on these numbers is always going to be the zoom, but occasionally focus will have a noticeable effect too. It depends on the lens. So at very minimum, you're going to need to do 2 runs of this, one at the far zoom end of the zoom and the other one at the near end. So in this case, in my case, it would be at 24 millimeters and at 70. Although it's better if you do several runs, maybe as 4, 5, or more at different settings, just to make sure. You can take a look at the output each time, and if the numbers are not changing very much, then you can probably stop. In any case, when you have encoders and you're going to deal with a zooming lens, you do have to go through this process multiple times, and it will take longer. I did post a link up above again to the process for the Glassmark or IndyMark lens encoders, and they give you some other ideas on how this works. The only thing you need to do now is transfer some of these files and things over to whatever your virtual production project is. What you need to transfer over is the My Lens file, the virtual production Fizz file, and the Cine camera setup that we did earlier, complete with the LiveLink bits and pieces and all that stuff. Then you should have a camera in your virtual production project that behaves just like it does here in the Calibrator, with everything properly calibrated and the distortion added. I'll do another tutorial after this one that shows exactly how to do that and what the results are, but I don't think you'll have too much trouble moving these 3 or 4 pieces over to whatever project you're using. Right now I just want to do a quick recap because I know this is a long and possibly confusing tutorial. So what we did is I calibrated my one lens for 24 millimeters. If you're using a prime lens or you only use your zoom lens at one setting, this is all you have to do. Now my lens is a 24-70 zoom, and if I wanted to use it at any of those settings, I'd have to calibrate it at least one more time for 70. And to get really good results, I'd probably have to do at least a few in-between settings as well. You'd do this by resetting the camera lens to whatever value you want, put matching settings in the Fizz object, and then redoing the calibration from the very beginning where you're capturing all the images of the checkerboard. This is necessary because the lens's distortion as well as the nodal point offset may be different at different zoom settings. Using the Fizz object will let you set whatever focus, iris, and zoom settings you're going to use during a particular take. Unfortunately, there's no way to handle zooming and things during a take unless you have lens encoders. That's all for now. I'll see you in the next tutorial.